So rather than kind of diving into a group of slides and going, look at our presentation, let me start off with, how many of you are pretty reasonably familiar with what Arista does? Okay, how many of you go, who the hell is this guy and why is he standing in front of me? Stephen. Enough said. Thank you, thank you. And Lorenz, you could raise your hand too. By the way, I'm accompanied by, as we've become a larger company since the first time, they've now assigned me handlers. These people's job is to keep me out of trouble and saying things that could, derail future corporate financial plans or things like that. So just so you know who all is surrounding me, and there is a reason they are positioned like this. Lorenz Redlifson is one of the lead software engineers, has done a lot of the PHY work and the physical integration, or the integration between some of the PHY layer and our switching system. He's also one of the very early software engineers in the company. How many years have you been here now? Almost 7 years. And Amanda Jaramillo is truly my handler. Her job is to keep me at the right place at the right time and avoid saying really stupid stuff, but also helps make these things happen here. And then Andre Pesh over here is also one of our software engineers. Andre, besides looking like Jerry Mathers in his wayward youth, also wrote a lot of the stuff we'll be showing you guys today. So what I wanted to do is like sort of cut out the marketing people, cut out the product managers and the people with titles like that and say, yes, these are people who really wrote the code that you'll see and runs on our switches. And so I also want to open up and say, what do you guys want to get out of the time we have together? I mean, what are the questions you would want to get answered? What would be interesting to you? Because I can shut the laptop, unplug the thing, and we can just have a conversation if that's more important to you than going through the other stuff. You have a comment, I know you do.
I do. Let's not do any marketing or business slides.
Okay.
Wait, no. I have a real important question. Forget that guy.
Can I get one
to say? What does Gartner think of you people? And in which magic quadrant are you? What was your revenue? How many employees do you have? Who were your investors? No.
What's your 5-year business plan?
Okay.
What's your position on software-defined networking and cloud computing?
Thank you. But let's keep it a little more.
In all seriousness,
thank
I'd
you.
like to know about the FPGA stuff you guys announced.
Okay. That's a legitimate one, unlike Steven's shameless pandering.
Burn, baby, burn.
Okay, so we'll talk about the FX platform. We can go through that a little bit. As far as, I'm with you, right? Let's cut out the fluffy slides. I'll probably have maybe one slide that just says one snapshot of where we're at, and otherwise I'll leave it alone. Is that okay?
No, that's fine.
Okay, cool. Otherwise I'll skip it. It's the first slide too. So, I actually used to do presentations. I put a slide up. I think I did this at the first Tech Field Day, and I said, you see this? This is marketing fluff. I will promise you we're not going to see any more of this, and then skip like the next 3 slides, which were shamelessly put in just for the purpose of winning the audience over for not putting in marketing fluff. It actually works really well. So if you catch somebody doing that, they're probably gaming you. So we'll talk about the FX platform. Anything else that is critical? I did hear SDN. It's a great acronym. What else?
Just let's talk about programmability of.
How about we actually demonstrate that? If I have somebody come up and write a new command.
I do have a much more basic question. I'm one of those who raised my hand when you asked, do you know what Arista does? And I basically said, no.
Okay.
You make some switches that I can see, but that's about it.
Okay. So who is Arista? We'll go through that real quickly. I have a little bit of content on that. Programmable stuff. Who we are. Okay. My handwriting's horrible, by the way. So let me hit a few of these topics. And as far as showing how the switches are programmed, we'll get into that. What we'll probably do is, rather than me tell you they're programmable, I'll probably ask Andre or Lorenz or somebody to come up and actually write some new commands and create a new capability on the switch in real time. It's probably a little more fun. So here was my fluffy agenda, talking software architecture, key capabilities. We're going to skip through some of that then and get into some of these areas and then come back to these aspects. So this is my one marketing slide. So it's suitably fluffy. But to give you an idea of what we do, we make 10 gig switches, primarily 10 gigabit Ethernet. We only position them into the data center. We do not do campus, we don't do metro, we don't do carrier Ethernet, we don't do mobile backhaul, and all these other interesting areas. Our rationale on this is fairly simple. It's a big-ass market. Right. It's a market that rewards value. There's a lot of value to be had. A question I often ask audiences, of end users are questions like, name a feature a networking vendor delivered for you in the last decade that's made your job easier. And you get the head going, struggling sometimes to think of one. Why? For the last 10 years, networking became the endless morass of press releases was bigger, faster, denser, cheaper, rinse, repeat. And what most customers are asking us for is, how do we make this easier to manage? How do we make it do something we want it to do? So our focus was, well, let me come back to that word. Our focus is we do one thing, 10 gig primarily, 40 also, gigabit Ethernet switches for data centers. We're trying not to be everything to everybody. Every company that ever set out to compete against Cisco and said we're going to do it and try to be everything for everybody has failed utterly. I would view those companies as companies like Extreme, Force 10, to some degree Foundry. Brocade certainly with the Foundry acquisition is a classic example of that. Look at Juniper's market cap pre-acquisition of NetScreen. Look at Juniper's market cap today. Tell me if Wall Street rewarded expanding their portfolio or not. If they're investors who look to them, probably looks like I think went 30 billion to 11 billion. But then look at the companies that are pure play, that do one or two things really, really well. And they have been rewarded for that. So our goal, focus. Do the thing we're doing really well. Try not to be everything to everybody. In fact, when we look at where do we go in data centers, well, now we have, compared to 2 years ago when we first talked, we have franchise wins, people who've deployed our stuff everywhere, yay, go us. The reality is we're still don't go in most data centers, everywhere in those data centers. A lot of times there's gig, we haven't won that. A lot of times there's general purpose IT, we're not there. Not because we don't have the features, but because it takes customers time to get familiar with something new in this area. So why rush it? And what we tell them is pick an area where we make sense, use us there. Right? Like you did with the Nutanix stuff and the VDI. Virtual desktops, good application, stuff makes sense there. Use it, you find, gosh, this works, it's not a problem. Equity trading plants were a big one for us on Wall Street. Cloud became a very big one for us with a lot of the top tier cloud providers now using a lot of our equipment. And the primary reason was price, power, the most important reason, flexibility, the ability to extend the capability of the box. A lot of the customers in that space have written a plugin or two that does something fancy or special. I can't tell you what that one is because it's different for every single customer. But when customers are able to extend the capability of a product to map into their workflow the way they want it to, you can do neat things. I'll give you one example. When you reload a switch today and it comes back up, that's great. What if when you typed reload, the switch snapshotted the number of MAC addresses it had learned, the number of routing peers it had, the number of LLDP neighbors it had, the number of ports that were up, which ports they were, and then what software version it was running and who typed reload. Now when the switch comes back up, it generates an email. And the email says, user Doug reloaded me 5 minutes and 30 seconds ago. When I went down, I had 42 routing peers. When I came up, I have 42 routing peers. Okay. I had 46 ports that were up before, I have 42 ports up now. Here's the ones that aren't. Danger. And starts going through a list of the common checks that we always try to do when a switch reboots. Why don't we automate it? We can. We can automate it natively on the box. It's not hard to do. But those are the kinds of capabilities customers start saying. Another one was, customer said, how do I track a route flap? How do I track a duplicate MAC address? You get the call, my VM disconnected. It said duplicate MAC address 2 hours ago. What happened? Have fun with that one. So now we log every MAC address learn, all ARPs, and all IP routes into an onboard SQL database. You can essentially create a command, show IP route at noon 3 days ago. It'll tell you what your routing table will look like at the time you care about what your routing table looked like, not just right now. Makes it easier to go back in time and troubleshoot a problem. So a lot of the things we do, companies talk about this fluffy, to your point, fluffy marketing term, solutions marketing. We try not to do that because it was like thin veneer of vertical of like finance, same network. Healthcare, same network. It gets pretty boring. We decided to look at it a little differently and say that there's sort of like 4 things we think we can do that are pretty powerful to our customers. And it's honestly making the guy who sits in the swivel chair really happy and successful. And it's things like, how do you upgrade software from one version to another as simply as possible? That's a pain in the ass today, okay? How do I manage congestion? How do I deal with the phone call that says the network is slow? How about I tell you when the network was slow, what ports it was slow on, what data caused it being slow, and hopefully someday soon I'll be able to tell you exactly what traffic was dropped because it congested. How do we do that? And then you pick up the phone, you call the application guy who was calling you, and you call him before he calls you, and now you're playing offense. That's a hell of a lot more fun. You call him up and say, hey, I did 4 concurrent vMotions off these servers at the same time with Intel Romleys on it, generating 18 gigs each. That was brilliant. You crashed the network. Way to go, Brainiac. They don't really appreciate that. But that's today they're calling you and saying the network's slow, it's your fault. It was slow 3 hours ago. Why? And the best answer we have is, well, how about we plug a sniffer in and let's hope it happens again and I'll tell you what caused it. That's not a good answer, but that's the best one we have. So you got to change it. Another one is how do we scale capacity out? Right? How do we plug new boxes in and have them hopefully increasingly automated learn about the topology they're plugged into, take the right profiles, the right access control, the right QoS class maps, the right OEM capabilities, turn all of those on, and implement them consistently. And then how do we have the ability to take a switch, have it fail utterly, completely die. Basically I want to do this. I want you to plug a switch in, I want to make configuration changes, may or may not type write mem. I want to do a demo where I can take a Desert Eagle 50 out, put 3 rounds in the switch, which Greg can't do in the UK. And then have the switch literally be completely dead. Amanda hates when I do this, by the way. This is when this is going to start vibrating in my pocket because she's sending me texts going, don't do that. No guns with the switches, Doug. But then I want to take a new switch out of the box that's never been configured before, plug it in, scramble the cables and plug them back in anywhere you want to in the switch, and turn back and step away and have the exact same policies appear against the end user devices that were plugged in, or the servers or the VMs. So that's one of the examples of something we want to be able to do. Those are game changers. What did you text me? You did text me. No. That was somebody tweeting something. But those to us are the solutions, right? It's not a thin veneer of vertical relevance in Sheen. It's what are things that change network operations and make the job easier? Because in the 1990s, Cisco rose to prominence not because they had the best switching hardware and not because they had the best routing hardware. They rose to prominence because they had the best software at the time that made network operations easier and gave us features to build better topologies. And I haven't seen a lot of capability. I saw the new internet announcement. That made me really excited. I read about it and there was nothing there. We're using BGP4 to build the internet. It hasn't changed, miraculous. So what are you doing that's different? And that's what we look at and say, what we can do that's different is make people's jobs easier. Apple built a business out of it, which is why I don't see a lot of PCs sitting in front of me. Sorry.
I think that explains.
These guys are working.
You see?
We've been segregated.
Yeah, we figured that out.
It's amazing.
It's nothing to do with bacon soap. Has everything to do with.
Nuts.
I'll get you a Mac. Don't worry.
Pass in the hole.
So when we think about where we do make sense, right? Again, we try not to say not everything for everybody, right? But Hadoop data mining, we've done some very nice integration work with companies like Cloudera there and Hortonworks and MapR, VM farms. Like what Josh was doing. Public-private clouds, some of the larger public clouds are using some of our stuff. Equities trading, risk analysis has been a big one. We talk about the FPGA platform, you'll see that. Exploratory geophysics is a nice word for saying big oil blowing explosives up in the water and mapping, sonar mapping the bottom of the ocean and figuring out where to drill holes. Signals intelligence is a government application for cyber warfare and targeting telemetry of foreign agents. So the one thing I will go into a little bit is the operating system. And when I say go into a little bit, this is the only slide. And then we'll get into the FX, and then we'll talk about how we're going to apply. You know what, let me actually skip. I'll hold this, we'll go into the FX platform and answer that question, and then we'll come back to this and go into the software. It's probably a little more contiguous. So with application switching, here's essentially what we did. We had this box. I don't have one here. We'll show you one as you walk out. The 7124SX. It's a really low latency 24 port 10 gigabit Ethernet switch. We put a bigger than normal CPU for what most networking companies put on it. A 1.5 gigahertz AMD Neo x64 CPU with 4 gigs DRAM, 4 gig NVRAM. Or 4 gig flash. we then said, okay, what's it take to run a computer, right? A computer is CPU, it's memory, it's I/O, it's persistent storage. So we had good CPU. I/O, we have 480 gig throughput. Memory, we put 4 gigs of DRAM on it. We said, well, we'll need more for application acceleration. We hold persistent storage. We put a 50 gig enterprise class SSD on the switch. And then we said, well, we have to accelerate things if you're going to do something fancy. So we selected the Altera Stratix 5 FPGA, the A7 model, which is 6.2 million programmable gates with 16 10 gig SerDes in and out, 8 gigabytes of external DDR DIMMs, and 216 megabits of QDR2 SRAMs. And we packaged that onto an application acceleration engine and actually put it in band. So you see these ports on the right. A better snapshot is, let me skip through the fluffy ones. Get you, here we go. Here you go. So this is the Altera Stratix 5. This is the Fulcrum Intel Bali chipset. This is the AMD Neo. This is the 50 gig SSD, 4 gig DRAM, 216 megabit SRAM, 8 gig DRAM. 8 front panel ports here, 80 gigs of SerDes through the custom switch ASIC, which is the Intel Bali, and another 16 coming out here. This lets us put the FPGA into the data path any way you want. A customer can take 10 gig in, do full processing here, 10 gig back out, bypass everything. A customer can bring lots of ports in here, use these as uplinks, guaranteeing traffic gets routed through it, do something interesting here, and route it on uplinks. Now the question is, what would people do?
So you can connect any FPGA output to any physical port of the switch? Or
Yeah, you pretty much can. I mean, you could do traffic this way if you want and bypass the FPGA, but with simple routing policy, I can make sure that doesn't happen, right? With the use of private VLANs, I can make sure that doesn't happen. So the platform, there's a better shot of it for you from the front. It's consistent with all of our others, dual power supplies, redundant fans, same exact parts, swappable across our entire 1RU product portfolio. What's nifty though is, and we'll get to the applications of the FPGA, we also put a clock input up there, a micro clock. Once our customers wanted accurate clocking, even in the lack of and connecting to a GPS clock receiver. So there we also support an onboard rubidium clock. A chip scale atomic clock is on board in the switch as an option as well. Yeah.
There's your eyes.
Where were you 5 years ago when I needed this?
I don't know, but I take POs today. So where do these make sense?
I keep raving about clocksync. This guy's got it solved.
So some of the applications, you can actually load an entire financial services trading plant onto the ASIC if you want, or onto the FPGA if you want. Now you're not going to do a really complex trading system and algorithms on it, but a VWAP calculation or a limit order book, absolutely. Large scale order cancellation, risk analysis is pretty interesting to run in line. If you look at the flash crash, if somebody was actually doing a simple calculation of what price should be, and if they give themselves a margin that they were allowed to trade up or below the price of something, it could have simply stopped the flash crash. Exchanges could then offer inline order or inline risk analysis as a service to their clients as well, which also gets interesting. When a really fun one, because of the clock source, imagine the financial exchanges, rather than running first in, first out processing when you get to their matching engine, they actually tag the packet with an RFC 1588 precision timestamp at point of ingress to their network, and then they can have full audit capability of who did get there first, who flooded the fixed port and who didn't, and can offer a fair equity trading environment for equities, derivatives, Forex, and so on. Government signals intelligence, radar systems is pretty cool. You get a lot of data coming out of a radar array, and FPGAs are commonly used in radar systems already for pre-processing that data and used for replicating that data to multiple distribution systems that then need to see that data, visualize it, then use it for fire control. Signals intelligence, interesting. The lawful intercept applications are rather broad for this. I don't know what you do in Slovakia, but in America, we like, with the Patriot Act, to be able to look everywhere.
Who's from Slovakia?
I don't know. I only know one person from Slovakia, and he might be in this room. The telecom market's also pretty interesting.
Nobody.
Slovenia.
Whatever.
Yes.
I was waiting for that. Because I do know where you live. The transcoding is also an interesting application. I could take a large upscale, high-definition video stream, put it out once into a CDN, and then down rev it to whatever the client's capable of receiving it at in hardware. So the CDN only has to store one copy. They don't have to move 15 different copies of it out there. You can do real-time transcoding for the client. But the most important thing is we do not own the intellectual property nor the software that runs on the FPGA at all. It is not ours. If you think of, let me give you a story of a bank. Let's say Morgan Stanley came to me and said, Doug, if you give us these 3 features, we're going to have an awesome trading plan. So we go, hell yeah, we'll do it. We build those 3 features. That customer gains competitive advantage for about 6 weeks. And then everybody else figured out what they did, and they turn up the same 3 features on their systems. So it's not very long that they gain competitive advantage. In fact, I can't find too many scenarios where you've actually used the network with the same vendor sitting everywhere to create competitive advantage from one company to another. Here, I do not own the IP. You do. It's yours. Actually, if you wanted to write an application to a hardware NAT PAT with deep packet inspection on this, you can. If you want to productize that as a new capability, go for it. If MBrain wanted to take their server load balancer and run it on here and use the FPGA path for acceleration and save themselves, I don't know, about 1,000 man-years of development of L2 and L3, they can.
So just to make it clear, so what basically calling your product a switch would be lying. Your product is actually a hardware forwarding platform, hardware forwarding application delivery platform.
It happens to be doing switching.
That happens to do the switching as a side thing.
Well, you see, now you get to one of the challenges, and is the role of network appliances. That whole world started with, let me take a server, let me put a fancy piece of plastic on the front, and I will not let you have any flexibility over what runs on that server, and I will sell it to you for an exorbitantly high price compared to what you could have bought the server for. Right? That was the sort of appliance market that was firewalls and server load balancers and became other things over the past decade. Inserting that device into the network is painful. So one of the things we wanted to stress is when we say it's a switch, this can construct a topology. This can run BGP, IPv6, spanning tree, God help us, multi-chassis link aggregation, lag, right? It is a fully capable network forwarding element.
So what have you done to the Linux kernel that's running the EOS? Or is that just to boot up EOS?
The Linux kernel, it goes back to one of the earlier slides, the one I skipped actually. A lesson from Unix is don't screw up the kernel ever. So we've made no kernel modifications.
That's assuming that Nix isn't already screwed up.
The what?
That's assuming that Nix kernels aren't already screwed up. I mean, seriously. So in the way that they handle networking, we had this conversation earlier. So what have you done in the Linux kernel to actually get rid of some of that silliness?
We have completely unmodified the Unix kernel because we're not using the Unix kernel for forwarding.
Okay, so that's my
So
question.
Right. We're not doing any forwarding through the control plane.
God forbid, kernel in the forwarding plane?
I know.
Yeah, that would be horrible. But so we don't do that. In fact, we also don't load device drivers into the Unix kernel space. We load them into user space, and we use UIO to move the PCI interrupts, convert them to messages and signals, and move those to the device drivers that execute in user space, so we can dynamically patch device drivers on the system and restart them as well. Just for the record, it's a 2632 kernel, Fedora Core 14.
Sorry.
Yes.
So with that FPGA, someone could actually put a firewall or a load balancer or whatever
Yes.
on that chipset. And
Yes.
Well, so can you
Ask. Ask. Ethan, hit it when I tell you to.
so let's quantify that, right? I mean, what? Give me some dimensions around this FPGA. Like, how much code can I load on it? How much traffic could I potentially inspect, right? Have you done any Arista or do you happen to know any numbers that people have?
The challenge on saying how much, like a DPI example is a hard one because the question becomes how many flows at what data rate, how much memory I have to store, and how much I'm inspecting, and what my grammar processing library looks like.
Okay.
So there's about 8 different variables in there. But I could tell you that I could do like hardware NAT at 160 gigs per second sustained throughput.
How many concurrent NAT sessions?
I have to do the math on it, but you can probably store, the sessions don't need to be stored in, so 8 gigs, 50 to, no, closer to 500,000 to 1 million.
500,000 NAT sessions, 100 and some gigabits per second.
Yes.
Through that FPGA.
Yes.
Okay, so we
Not
haven't
state
heard
small.
that. Could you please repeat that? Because numbers seem awesome from here.
Oh, here.
I have to ask. I mean, are these real numbers or this works fine in PowerPoint?
Did you
Oh,
just
everything
make
works
that
great in
up?
PowerPoint.
No, I know that. This is why I ask. I mean,
No, so let's be pragmatic here. We have 6.2 million gates, right? You have 216 megabits of SRAM. This would be used for storing anything that you're going to be doing inline processing on. There's additional 50 megabits on the FPGA itself. There's 80 gigs of data path this way and 80 gigs of data path this way, another 80 back, another 80 back this way. So could I move 80 gigs in and 80 gigs out, 80 gigs back in and 80 gigs back out through the system concurrently? Yes, the data path will support that. There's 6.2 million programmable gates, and you have to figure out how many gates it's going to take to run your NAT engine. If it's static NAT, it's not that difficult. There's not a lot of state you're managing. Right? So the state of a static NAT session could actually be stored in DRAM. It's not too difficult there. If you start talking about dynamic NAT.
But the point is, when we start talking about the state, we have to keep in mind that that state needs to be maintained. So, and what you are talking about is the real-time calculation. But these things don't really happen in real time, right? Because you have to maintain the state even when there are no packets flowing through, because the traffic is bursting, right? So the number looks nice.
No, I would say a static NAT session, you're pre-programming in anything from this source is going to write to this destination.
Okay.
That's a very small state
one to
table.
one.
Yeah.
Okay.
A dynamic NAT's more challenging.
Yeah. So you
Fair
could do 80 gig of static NATs or that.
Yeah. I think that's pretty handy.
But static NAT is really no different than just
But
forwarding with.
You know what you're also going to find though?
Well, but could you? I don't think you could do V4 to V6 with this. Yeah, you could.
You know what? The interesting thing is,
Now, Marco, find me another 80 gig 6 to 4 load balance.
No. I'm not saying that this is not impressive. It's just that I said I'm a man on a mission. I have to find something wrong with it.
Well, so when you say dynamic NAT,
let me throw one caveat out for everybody. How many people here can write VHDL?
What?
VHDL. How many people here write Verilog? I've had to do it before, but I mean, how many of you can write Verilog like without reading a reference manual? Okay. If you use a C2 RTL or Verilog compiler, which we support with our partner Impulse C, you could write a C program. It will parallelize it and write it into VHDL or Verilog, which then will load into the FPGA. You'll be able to do some stuff with that. Unless you're writing it natively in Verilog, you will not get an equal performance capability. The application of this in most cases is not end users like us, right? It's a company who is already funding FPGA development that says, I can accelerate my path to market by not having to build all this network stuff and package it. Or if you look at one of the largest users of FPGAs over the last 5 years was the government with signals intelligence and cyber warfare work, and the financial services market, buying FPGA accelerated NICs and loading their trading plants and loading order gateways and feed handlers and data feed normalization into them. So I usually start this one presentation off, there's a slide I wish I'd put in here. It has a giant freaking Swiss Army knife. It says this is not what we've built. Okay, this product is not for everybody.
Okay, but
Yes. And then, I owe him this question as well, but go, Brad.
Did this come out of those customers, or is this something we were looking for differentiation in?
Yes to both. We have
I mean,
20
you may-
plus financial services customers testing this product and using it today.
You may have not been building a Swiss Army knife, but it looks like you actually built one. It's just not very user friendly, or it's picky who the friends are.
You said the Andy knives.
Yeah. We just need to be careful because I'll tell you what happens
It's a
here.
sharp knife.
What happens with this is like what happens with technologies like OpenFlow. Okay, if you've ever looked at the OpenFlow spec, if you look, I did. If you look at the OpenFlow spec, okay, it looks reasonable. Try writing to it. Most of us here probably couldn't write to the OpenFlow 1.0, 1.1, or 1.2 spec and get a workable operation out of it. So here, what's the reality of it is it's a small market for the product. It's not for everybody. And what happens is people will see it and will start asking all the questions we're asking here. And they're good questions. I like them. I love going, wow, I could do. It's fun. But at the same time, we have to be pragmatic about what it really can do, what it can't do, and to some of the questions you were asking. And make sure that, okay, rather than rushing in buying one, I don't want to tell a customer, go rush and buy it and figure it out, because then they're going to fail. I'd rather sit down and say, okay, what's your exact application? How much data? How many sessions are you going to terminate? Let's map that out and say, is it going to work for them or not? And then we can say, is it worth going any further and developing on the product? Because we don't want to say, here, take it, and have people fail with it. I've seen that happen too many times with too many promised God boxes. We don't want to do that.
But you brought up this interesting statement that this probably isn't for a lot of us.
Yeah.
As soon as you brought this up, I know for my business application right now, I have an application for this.
Okay.
And you brought it up, it's video transcode. I just spent an incredible amount of money and a vendor who is on the market who does video transcoding and doesn't do it at nearly the lows that you're talking about doing.
It's entirely possible.
At some point in the scale of my business, if we grow into multi-call centers and all these other things, it makes a whole lot of sense
Might
for
be
me
worth
to
it.
hire a developer who does it in this language called Verilog that I've never heard of, and actually designs an in-van, real-time, 80 gig transcode environment for me, that then I buy your switches and I drop it on there and go. And I think we'll all find point use cases of this over time.
So we recognize that the market for it, again, isn't everyone, but a lot of us will be able to find an application.
Absolutely.
And so we kind of went for 3 development models with it. I'll kind of go back. One is the full custom model, where if you have the resources, you can program it in-house. When somebody wants to create and sustain competitive advantage, that might be the right way to go. When somebody wants to, in your world, maybe outsource the development to get a unique capability, you can partner with companies we've worked with who have the IP blocks to bring it up, and they can enable that. And then the market, I think that's going to be the mass market, is kind of when you ask, could I put a security appliance on it? Could a load balancing company? Yeah, the off-the-shelf market is where somebody takes a existing product, ports it to it, and then they buy that product, load it on, knock yourself out. And that can be a tremendous acceleration for a lot of those guys to create or to save themselves hundreds to thousands of man hours on having to build that underlying network platform, which is not their core competency. Right? We want them to build the best SLB code out there, the best application front end, the best security appliance, not have to worry about the underlying BGP code, right? And be able to transparently insert that into the topology. So that's kind of, you asked about the FX. I want to give you the kind of snapshot of it. And then, like I said, we've partnered with companies who can deliver that. And we're adding to this list over time. Some are already completely integrated applications. Note what markets those are for. It does align very well with where we said the product is very strongly positioned in the financial services space. And then other companies we've been working with to do more customization for end customers. Let me skip back a slide or two, and I'll touch on the last slide, and then I'll introduce Andy. Yes, sir.
Did you add Altera as a development partner?
I did not. I will.
So Altera makes the silicon, the FPGA, and they have a complete tool chain of how to program FPGAs in Verilog or VHDL. So the way FPGAs are built today is typically in a hardware description language, which is very different in the software environment. But you can do that too, of course. So that's the hard way of doing it.
I will go add them to the slide after this immediately. So one thing I started off with, we're a software company. And as much as we do, and sometimes I think this, Andy hates when I say this, but we have about 200 software engineers. We have about 10 to 15 hardware engineers. That's an amazingly small hardware team for the amount of hardware we produce. We hired 17 hardware engineers. I can never keep the numbers straight. I need like XML code in my slide that goes and pulls and updates it off of our HR system to make it easier. The growth rate's pretty astounding. But one of the things we did really, really right is if we crack some of the boxes open, you'll see that every 1RU switch uses the same fan, same power supply, same CPU board. We don't have to go and reinvent the wheel every time. Now, that means our customers get common sparing and they can port things around. It means we get the similar volumes like what a Cisco business unit gets, but we're not distributing it across 25 different product lines focused on 30 different markets. We're getting them for a consistent set of every product we build using as much common hardware as possible. That also means quality goes up, because once you figure out how to build it right the first time, you nailed it by the third time. And by the 10th time you're doing it, you're not getting a lot of defects. So new bring up's quicker. But at the core, what our customers interface with more than the hardware is the software. That's the day-to-day interface most people experience. And that's where we put the bulk of our software engineering resources. Now, again, we focus on data center. We don't have 100% feature coverage yet. When I joined the company about 3 years ago, we had just shipped Spanning Tree. Okay. Now, that's an interesting tale, because you're like, oh my God, how am I supposed to sell this switch to somebody, and we just shipped Spanning Tree? Really? You're kidding me. We don't do static routing yet? Fortunately, since then, we've closed that gap. OSPF, BGP, IPv6, management VRFs, and private VLANs, and so on and so forth. What's really interesting for us is at this point, the feature velocity our software engineering team's been able to hit, and we'll talk about why, has allowed us not only close that gap markedly, but I believe in the next year, there won't be what I call a tier 1 feature left. And by tier 1 feature, I'm talking like 20 engineers for 6 to 12 months of development. So what do you do then? Well, then you focus on the fun stuff. And the fun stuff is all the differentiators. All the things that everybody's wanted to do but could never do before because they spent so much time doing platform support, which are problems we don't have because of the software architecture. And that comes down to 4 things that Ken Duda, who leads our software team, puts up. And this is kind of Ken's slide. But the first, and kind of the question in the corner, was lessons from Unix. And the first one was, don't screw up the kernel. Too many networking companies like to go and screw with the kernel. We made BGP perform better. We have a better implementation of SSH. Knock yourself out. The first time there's an SSH defect, guess what you're spending your time doing? Figuring out if it affects you or not. What do we have to do? Oh, somebody already fixed it in 48 hours in the Linux community. We didn't modify our kernel. We can ship it as a patch really quick. Lessons from IT. The IT lesson.
Just tweak to why you're SDN, why you're not big on OF. Because you're already doing software defined.
Probably. I think that's a very fair and accurate statement.
You're not particularly focused on using OpenFlow to do it. You're going to do it in your existing control plane.
I'll tell you, we'll be doing an OpenFlow announcement sometime.
Good point. I have a follow-up question.
Yes,
Now, everything that we talked about deals with a single box, with a single unit. How does it behave? How is the communication between these devices done if we want to compare it to SDN? Which is, I think that is not what you are doing. I think there is a big difference, because everything that you talked about is now how do we make a single unit behave as a programmable platform. But what if I have a network of those units?
Yeah. It's like any network, we started with all the open source and open standard protocols. So OSPF, Spanning Tree, link aggregation, LACP, LLDP.
I'm more talking about the custom applications that can be built.
We allow a variety of interfaces into the system for programmatic. We could probably demonstrate adding an IP sockets interface in about 2 minutes to execute any command you wanted. Full Python local for local APIs. Adding netconf is the first for remote APIs because it's one that was designed for networking. And again, sticking to the standards. You probably will see, I won't say for certain because we haven't announced it, but I'd say you probably will see an OpenFlow client support for our product at some point. Probably not too far out, but it's something that, to me, OpenFlow doesn't, and I'll wax eloquent for a second, I don't think it's going to revamp the way people design network forwarding and network topology construction, but I think it's a perfectly viable protocol for the creation of centralized policy and the distribution of that policy to be executed across a multi-vendor array of devices.
It also talks to things that you're talking about. You talked about VMware instances migrating, coming up and saying, where's my 42 neighbor? Those software features that add value to networking, make it possible. That to me is SDN. I'm not.
And that's a lot of the stuff that's there today.
Yeah, I'm not fussed with OpenFlow. What I want to get away is waving my fingers on a keyboard to configure a VLAN.
Yeah.
I want software to do it for me.
Yeah, I mean, we could.
I'm not bothered if it's done using netconf or Yang or SNMP.
You just want it to work.
That'll never happen, but
You want it to work and be automated,
yeah.
right? And you don't want to be chasing around the virtualization guy every time he moves a VM and going, where do I have to create another freaking VLAN?
Yeah, that's exactly right.
So for that we have native connections to VMware vSphere, vSphere 4, 4.1, 5, and we'll dynamically and automatically provision and provision VLANs, deprovision VLANs, prune and unprune VLANs on queue trunks within allowed ranges per vSphere instance. The lesson from IT, by the way, is the 3-tier architectures that we started learning to deploy in the 90s, where you had your web tier, which takes user interface and connection management. You had the application tier, where logic is executed and scales out, and then your database tier, which stores all state. So our OS architecture mirrors that. State is in a separate in-memory database which is dynamically created at build time based on the requirements of all of the applications to publish and subscribe different state changes to each other, which eliminates all the message passing between all the different applications. The short version is, if I went into a core switch on this network, and I might ask Andre to do that in his demo, and do a kill-9 of the spanning tree protocol, you will not see a link flap. The new spanning tree instance will start back up. It will remount the last known state from the state database and restore itself, and therefore know the listening, learning, blocking, or forwarding state and the current spanning tree state in which BPDU sequence numbers are being transmitted. So you do not have to relearn the entire topology, which would disrupt the entire topology because a single application had a slow memory leak and was killed by a watchdog process that Lorenz wrote. Lessons from the cloud were automate, automate, automate. And I think you guys already hit on that, so I'm not going to go into that any deeper. But the one other one is extend, extend, extend. Right? If you have to be able to extend the operating system to customize through customization, customers can create competitive advantage by increasing their operational capabilities or decreasing their costs. And so by allowing our customers to customize the capabilities of the product, they integrate it better and more seamlessly into their operating environment. And then the last one is lessons from competitors. When we've seen competitors do some really brilliant things, we've seen some competitors do some not so brilliant things. The biggest lesson I would say is the one of focus. Right? The most successful companies in IT infrastructure were ones that picked one thing and did it really well. And so you're not going to see us chase every interesting little opportunity. You're not going to see us building load balancers and firewalls, and trying to be everything to everybody. You're going to see us build a really good switch. In fact, I want to partner with all the load balancing and firewall companies and be the only infrastructure company that doesn't compete with them. Find that they like to work with you more often when you're not selling products that compete with them. It's a very interesting model.